look at Bayes' theorem. Whoops, I did it again. Bayes' theorem. This is Theorem 2.2 in the text, and it says that for events A and B, that the probability of B given A can be written as the probability of A given B times the probability of B over the probability of A. So all they've done is they started with probability of A given B, and that's the probability of AB over the probability of A. But then just conditional probability, right? Conditional probability says probability of A given B is equal to the probability of AB over probability of B. So now move this over to that side, and so we get our probability of A given B times the probability of B over the probability of A. Now, if we then look at the theorem of total probability, and suppose we start with just two events as far as B goes, B and B complement, and so we've got B plus B complement is the whole set S, and so that means I could write, and they're disjoint, that's why I put a plus there. So we could write A as equal A intersect B plus A intersect B complement. And so this thing up here that we had, so now I could write P of B given A is our P of A given B times P of B over P of AB plus P of A B bar or B complement. And then I can write each of these similar to this using the conditional probability in multiplicative form. And so I have my P of A given B, P of B over, again, P of A given B, P of B. That's the first part here. And then plus P of A given B bar times P of B bar. And actually, we tend to see it something like this. And even more generally, if we, let B, if we take a set of B sub I where the sum of the B sub I is equal to the sample space. So again, by using sum, I've said these are disjoint. Okay, so they're disjoint. And then by saying they equal the sample space, they cover everything. So if we do that, then I can take Bayes' theorem and write P of BI given A for any given BI is then equal to this probability of A, oops, get these in the right order, A given BI times probability of B sub I. And so if you look back here, this BI is kind of taking the place of B that we had up here. And then you see, so this would be a given BI here, like this. And then, you know, but all this was that I could write then the P of A that goes in the bottom down here. I can write it as the sum over all the I1 to n, of these P of A given BI times probability of BI. So it's the sum over all of those. And all that was happening there was we took A and we said, well, A I can write as the intersection with B1, A with B2, and then up to A with Bn. So I can write A as this union of disjoint sets by using the different BIs. And so for any one of them, you know, if I want to look at B1 or B2 or whatever, I can set up Bayes' theorem this way. So that's a really nifty thing with Bayes' theorem.